Okay, I'm going to go over the matter concept map one more time because it is important that you remember this. So matter can be broken up into pure and impure substances. In order for it to be broken up into a pure substance, it either has one element, or it has one diatomic element, or the same compound. So an element, just to go over, that's a single atom. It's alone, which means no bonds. For a diatomic element, this is two of the same atoms bonded. Okay, these guys are the twins. They're the duos. For compounds, this is a molecule that is bonded and we're going to include differently. We're bonded with different atoms there. I like that better. Okay, so this is also a molecule because there's more than one molecule and there's bonds. So think of molecule as married. But yeah, diatomic, two of the same compounds, they're different atoms. For an impure, that is some kind of mixture. So we have homogeneous or heterogeneous. And in homogeneous, this is a solution, so it looks all the same. So it looks like it just has one phase. So it looks like one phase. Whereas heterogeneous, we can call that a mechanical mixture. Mechanical mixture. And it looks different. You can see the chunks. So there is a review. So matter can go physical changes. So we talked about that already. And then it can go through chemical changes, which we'll learn today. So first things first, a chemical property. So the definition of a chemical property, and put this in your notes, the ability of a substance to combine with or change into a different substance. Here are some possible indicators of chemical properties. Yes, this is in your notes, but later on in this slide, I'm going to give you a condensed version. So indicators of a chemical change are if it absorbs or releases heat or energy, if it's combustible or flammable, forms a gas, reacts with an acid or a base, reacts with water, and this does not mean dissolving, so not included dissolving. If it was to dissolve, remember that's a physical change. So this is reacting with water and it changes into something new. If it forms a precipitate, that means solid in a solution. If it changes color or if there's a change in odor are all indicators of a chemical change. So these are chemical properties of a substance. So a chemical change is when one or more substance changes into a new substance with new properties. We also call this a chemical reaction. So chemical change, chemical reaction, same thing. Chemical changes are more difficult, sometimes impossible to reverse. So this I want you to write in your notes. So this is under the section called chemicals. So chemical changes must have either, and then here's the first one, molecules to atoms. So, and hopefully, I don't know if I can do this in present mode. Ooh, I didn't think of this. Okay, hold on. I need to. Okay, here we go. With your molecules to an atom. There we go. Now it's going to let me select. this molecule, and in fact it's a compound because there's different atoms, that's going to break apart. Ooh, these atoms aren't looking very good anymore. Oh well. Okay, so they're going to break apart. And now we have all these single atoms. So we know a chemical change happened because this compound broke apart and we have something brand new. We have some oxygen, we have some sodium, and we have carbon, and they're all separate now. But same if it was the reverse. If we went from atoms to molecules. So if all of a sudden this chlorine bonded with this calcium, now we have a chemical change. We created something new. And then if we ever have a situation, this is number 3, if bonds are broken and are completely reformed. So if we go ahead and we break this up, and let's say now, game in. Okay, you know what's going to be easier? I'm just going to go ahead and draw this. So this compound, this diatomic element, is now going to change into maybe hydrogen. Maybe we have a diatomic or a new diatomic element, and maybe we have oxygen bonding with 2 hydrogens. So now we have H2O, some water, and then what have we got left? We got this carbon bonding with, we'll go with oxygen. There we go. So we have bonds that are broken, and we have completely new molecules. Let's go back into, there we go. So let's look into physical characteristics of magnesium. So first, what chemical changes would you like to try with magnesium? And what are the physical characteristics of magnesium? Let's list this first one. All right, so physical characteristics of magnesium. Magnesium is silver. It is a solid. It's ductile. It's a conductor. It's malleable. And it is a metal. All right, so here off to the side I got some magnesium atoms, and then I have some diatomic elements of oxygen. So we can light this on fire. So if we were to light magnesium on fire, we're going to get some new bonding. So what's going to happen now is that magnesium will bond to oxygen to create something new. And this chemical formula, first we started off with magnesium as a solid, and we have oxygen, which is a gas. And if I was to light it on fire, we're going to have a chemical change, and they're going to bond. Magnesium is gray, oxygen is colorless. When we mix them together, we're going to get a solid, and it's going to be a white powder. So that's completely changing it to something new. And what I want you to do is, this is going to go into your notes, and it's near the bottom when it mentions about physical changes in the classroom, or that we've gone through in the classroom. That's where I want you to put this. So I want you to write out this chemical formula, and go ahead and draw this picture as well. Let's look at magnesium with hydrogen chloride. So if we were to put it with an acid, what's going to happen with magnesium if we put it with an acid? So now what's going to happen is we're going to get new atoms, new molecules. So hydrogen will form with chlorine. Or sorry, that's not what I wanted to say. We already have hydrogen forming with chlorine. So this is that hydrochloric acid. We would get chlorine bonding with magnesium. And then that hydrogen is just going to create a diatomic element. So they'll bond together. So my chemical formula there, we first start off with magnesium, which is a solid. And we have hydrochloric acid, which is an aqueous solution. AQ means aqueous solution. And once we combine those two, we get something completely new. So we create an aqueous solution and hydrogen bonds. So we get energy produced and gas is produced. So also add that into your notes. All right, so I'm just gonna have to quickly run through some of these slides because we're gonna do this in class. But this right here is the shortened condensed form that I want you to put down for indicators of a chemical change. We have a change in color, number 1. Number 2, a change in odor. 3, a formation of a gas. So formation of a precipitate would be number 4. So this is also known as forming a solid. Or if we have a release or absorption of energy. And how we would feel that, or how we know that would happen, is a release of energy would be like a release of heat. We'd feel that warmth. And an absorption of energy would be cold because it's taking our warmth from us. So these are things that I want you to memorize. Okay. And let's go to some examples here. All right. Does not matter about what we have for compounds or molecules. We started with the left, and now we went through some chemical change, and we went to what's on the right. Was this a chemical change or a physical change? Do we have something new or no? If you said new, you'd be right, and I kind of gave it away because I accidentally said chemical change, but it absolutely is a chemical change. If we are rolling a boulder down a hill, is this a physical change or a chemical change of that boulder? When it reaches the bottom, is it something new? No. It's a physical change. Or just, yeah, sure, physical change. Nothing's happened. Still the same rock. Right, we go from these compounds to the compounds on the right. Are they different? Yes. So this is chemical. What about these wind turbines spinning? Is that physical or chemical? Are we changing those wind turbines? Nope. Physical. All right, we have carbon bonding with oxygen on the left, and on the right we still have carbon bonding with oxygen. All that's happened is that on the left we have these free floating compounds, and then on the right they're stacked together. Did anything change? Do we have something new? Nope. It's physical. And then hitting a baseball. Is there anything happening that we can't possibly reverse? Nope. Physical. Okay, so I want you to go through your practice questions. So you have a sheet on physical properties and another one going through physical properties and the changes in reactions.